We started with surds. So in our test we've got our surd operations. Okay, so surds, they're numbers expressed in a root, and we're talking about adding, multiplying, dividing, subtracting surds. Probably the only thing I'd want to point out from there, like 12a1, 12a2 is very, very basic. Like if you have 3 lots of root 5 plus 5 lots of root 5, okay, that's what that means. It means 3 times root 5. That would add to 8 root 5. So it's just like terms. One thing we do in there though is rationalize the denominator. So if we have 1 on top of 2 take root 5, and we want to what's called rationalize the denominator, that means we want to write the denominator as an integer, as a whole number. We have to multiply by the conjugate. And so the conjugate of this here is going to be 2 plus root 5 on top of 2 plus root 5. Okay, if you perform that, that's 1. So we're not changing the value of this in any way, but what it allows us to do is difference of 2 squares at the bottom there. At the top, you're just going to have 2 plus root 5, but at the bottom you've got a take b times a plus b, which simplifies to 2 squared take root 5 squared, and we can simplify that. 2 plus root 5, that's going to be 4 take 5. It's going to be 2 plus root 5 on minus 1, which is minus 2 take root 5. Okay, so we started with this, and look what we simplified it to. Alright, so that's what we're doing in 12a. In 12b and 12c, we cover index laws. Okay, we've been doing index laws for a very long time. So yeah, simplification using index laws. 12d, scientific notation. So keep scrolling through with me. 12e, we get to rational indices. And so that's something we're beginning to get a bit of a look at, is square root of a, well that means a to the power of a half. The cubed root of a means a to the power of a third, and so on. The nth root of a is a to the 1 on top of n. Very good, that's in E. Then we get to F, where we looked at expansion and factorization. So let's just pluck a random one out. Let's do 12F.1 question H. So that's going to be 5 to the minus x times 5 to the 2x plus 5 to the x. Okay, it wants us to expand this. So when we're expanding, we're going to apply the distributive law here. So this term is going to distribute here and here. We're going to have 5 to the minus x. I'll write that nice and slowly, times 5 to the 2x, and then plus 5 to the minus x times 5 to the x. Okay, now these have the same base, which means we can add those powers together. So we're going to have minus x plus 2x. That's going to simplify to 5 to the 1x. Okay? And then over here we're going to have 5 to the minus x plus x. That's going to be 5 to the power of 0. And that simplifies to the 1. So we'll have 5 to the x plus 1. So that's expansion. And then we did a bit of factorization as well. So let's pluck one. So that's 12F.1. And then factorization, let's go for this one. We've got 6 to the n plus 2 takes 6. And it wants you to factorize that. So that means you need to figure out, well, what's a product that's common to both of them? So 6 to the n plus 2, if we think of reverse index laws, that's going to go to 6 to the n times 6 squared. Okay? And then that's take away 6. So what is common between this term and this term? Well, it's 6 to the power of 1. So we have 6 is common. And what are we left with? Here we're going to have 6 to the n times 6 to the 1. Okay, that's gone from there to there. And then here that's going to be 1. If you expand this, all right, you're going to get the minus 6 there, and 6 times 6 is 6 squared there. And so what's the best way to write that? It's 6 times 6 to the n take 1. Okay? So that's F. Then in G, we did solving exponential equations. And we did that by equating the base. So we'll just, again, do this one. 3 to the x is 2 times 3 times 2 to the x is 24. Okay, so when we want to solve by equating the base, or even if we're solving by using logarithms, we're we're going to start by dividing both sides by 3, because we want to isolate that exponential term by itself. So we'll have 2 to the x is 8, and then we want to express 8 as a power of 2. We'll have 2 to the x is 2 to the 3, and equate the powers because the bases are the same. So that's how we do it by equating bases. So that's 12G. Then in H, we looked at graphs of exponential functions. So we're using our calculator a bit there. And so we have graphs of exponential functions sort of look like this. They have the form y equals, how do they express it here? K times a to the x takes c plus b. Okay? So x is our variable, c is going to affect horizontal translation, b is going to affect vertical translation. But the key point of this is that this number at the end is always the horizontal asymptote. Okay, it's always the horizontal asymptote. So if you have some exponential, 2 to the x plus 3, the asymptote is y equals positive 3. Okay, if you have 2 to the x take 5, the asymptote would be y equals minus 5. So that was in H. And then in I, we looked at growth and decay. We've done that in year 10, we did it in I, and then we did it again with logarithms just last week. So that was both I1 and I2. Okay, then we skipped J. We did it as a bit of extension, not that exercise specifically, but we did talk about E. So E and Ln will not be in the test. So then let's move on to 13. We looked at logarithms in base 10. So come back up here. Alright, so if we have log of 100 on the square root of 10, okay, what we need to do is express it as a single power of 10. So here we've got 10 squared, and at the bottom we've got 10 to the half, and then they're the same base, so we can do the top power take the bottom power. So 2 take a half is 3 on 2, and then because we've expressed it as a single power of 10, it can simplify to the integer. Alright, so that's logarithms in base 10. And then we looked at logarithms in base A. So it could be any number that's the base. So for instance 2, and if we have 8, we need to express this number as a power of 2. So log in base 2 of 2 to the 3 simplifies to 3. So that's 13A, 13B. Then in 13C we did those laws of logarithms. So that's like log 4 plus log 5, okay, equals log of 4 times 5, log of 20. Alright, we've seen them a bit. Natural logarithms we're going to skip, not going to be in the test. So that's 13D1 and 13D2. And then we did solving exponential equations using logarithms and growth and decay with logarithms, which is pretty fresh, we just did on Friday. So that's a summary of the unit. I'm going to put up on the whiteboard here some the questions from the review sets, and you'll find both practice tests there ready to go. So I think there's 4 practice tests on the sector. I've printed 2. If you want me to print more, let me know. You can proceed. If you want me to print more for you, let me know. But we'll start with that, and I'll put some review set questions up that I recommend doing as well. Okay. So on Thursday, we're missing lesson 7 because of the charity day. So on Thursday we're going to come here, we take the roll, and then so we'll have all our stuff here. We'll go to the gym, we'll come back up here once we've been down there for a lesson, and then have our lesson as normal. My plan would be to continue to do the test on Friday, but I would like to consult you guys and see what your opinion is. Okay? Because your opinion matters. Okay, so let me write some questions up. You guys get into some revision, whether it be practice test, writing a cheat sheet, standard cheat sheet applies, single side, single page, A4 notes, handwritten. So that's all the same.